Here we have a circuit diagram and you are to determine the current flowing through the resistors. Here we will use the mesh method. Here we have the sign convention for the mesh method. First scenario, the assumed current flow moves from a low potential which is the negative to a high potential which is the positive end. The voltage will be a positive value as shown in equation 1. Similarly, resistors having the positive and negative end will have the same sign. Note that the direction of the current is assumed only and it may or may not be true. Also, the positive and negative signs for the resistors are also assumed. In contrast, when the current moves from a high potential to a low potential will have a negative value of their voltages. This is true for both voltage source and the resistor. Now let us go back to the problem. We first assign the positive and negative ends for the resistors. The signs for the voltage sources are unaltered since they are already correct. Similarly, we draw the assumed current flow for each mesh. Here the first mesh has a current of I2 and the second mesh is for current 3. Let us examine the first mesh. With respect to the voltage A, the current moves from the negative end to the positive end. This suggests that the current is moving from a low potential to a high potential. So, the sign for the voltage 1 is positive. For the resistor's sign convention, we assume these plus and negative signs based on the direction of the current loop. Here we assign that as the current enters the resistors they are expected to drop from a high potential to a low potential. So for resistor 1, the current moves from a high potential to a low potential so its voltage is negative. For resistor 2 which is between two meshes, there will be two sets of positive and negative signs since we have two sets of assumed current direction. For the first mesh with current 1, it has a positive sign on the top and negative sign on the bottom. This suggests that there is a voltage drop since it moves from a high potential, the positive, to a low potential which is the negative. Now for the second current I3 from mesh 2, we see that the current enters the bottom part of resistor 2 and we take this as the positive end and it goes out at the top end which we take as the negative end. This behavior suggests that there is a voltage drop as the current 3 enters the resistor. For resistor 3, the current 3 enters on the left side and we take this as the positive end and goes out at the other end which is the negative end. So there is a voltage drop as it passes through the resistor 3. Finally, for the voltage source VB which has a fixed orientation of the positive and negative sign, we see that the current moves from the high potential towards the low potential so it has a voltage drop behavior. Now let us proceed in writing our Kirchhoff's voltage rules for the mesh method and we consider the first mesh or loop. So first we consider the sign for voltage A. Since it is moving from negative to positive end or from low potential to high potential then it has a positive value. With respect to resistors 1 and 2, we see that the current 1 moves from the positive to the negative or moving from a high potential to a low potential. This gives us that the resistors have a negative value based on the direction of the mesh current. However, there is another current moving through resistor 2 which is current 3. So, considering the direction of current 3 we see that it is moving from the negative end to the positive end or it is moving from a low potential to a high potential. Then with respect to current 3 the resistor will have a positive voltage. The relationship among these parameters is written in equation 5. We group like terms and we see it in equation 6. We then substitute the known values and finally we have equation 7 as the simplified equation for this mesh. We then examine the second mesh. With respect to the voltage source VB, it moves from a high potential to a low potential, so, we have a negative value of the voltage source. With respect to the second resistor, current 3 moves from a high potential to a low potential so we have a negative value for the voltage. However, resistor 2 has another current flowing which is current 1. For current 1 it moves from a low potential to a high potential. So, it has a positive voltage due to current 1. And for resistor 3, the sign for the positive and negative end is based on the direction of the current loop. So, we assume that it loses its potential, so its positive end will be on the left and the negative end will be on the right. So, resistor 3 has a negative voltage. This is shown in equation 8. We then group like terms shown in equation 9. Simplifying it further, we get equation 10. Here we have equations 7 and 10. Multiplying both sides in order to cancel one of the terms when adding them together. Here we see that we multiply equation 7 with 5 and we multiply equation 10 with negative 2. We see that the third term related to current 3 cancels out. We then rewrite the equation and arrive at the value of current 1 as shown in equation 11. Current 1 is about 1.09 milliampere. Substituting equation 11 or current 1 to equation 7, we arrive at the value of current 3, which is shown in equation 12. Current 3 is a negative 1.36 milliampere. The negative sign simply indicates that the assumed direction is incorrect in direction. For the resistor 2, we have two equations from mesh 1 and mesh 2. So due to mesh 1 we have equation 13 and due to mesh 2 we have equation 14. Substituting the known values we obtain two values, one is a positive value and the other is a negative value. Since mesh 1 gives the higher current value for resistor 2, then we choose this as shown in equation 15. Its direction obeys that of mesh 1. The initial current direction is not all correct since one of them is negative. Here, it would be the third current which is a negative value, and to correct this is to simply reorient this as shown in the figure. We then change the sign to positive from negative. Now let us look at the problem but with the direction of the current flow is counterclockwise as shown on the figure. We notice that the signs of the positive and negative are changed. For resistor 1, the high potential is now positioned at the right side and the low potential or negative sign is on the left side. For resistor 2 with respect to current 1, the bottom side is now the location of the high potential and the top side is the low potential. Now with respect to current 3, the resistor will have its top side positive and the bottom side as the negative. For the resistor 3, the right side is now positive as current 3 enters it and negative on the other side. So, we see that for currents the sign convention is assigned in order that there will be a voltage drop as the current passes through it. So we see that for mesh 1 the relationship is given by equation 16. We then combine like equations as shown in equation 17. Substituting the given values and we obtain equation 18. For mesh 2, we see the relationship of the parameters is given in equation 19. We then group like terms as shown in equation 20. Further simplifying this by substituting the known values and we get equation 21. Here we add the equations 18 and 21 for the two meshes. Simplifying further we get the value of current 1 which is shown in equation 22. Here we see that it has a negative value. This suggests that the assumed direction of the current is wrong and must be reoriented later. Substituting equation 22 to equation 18 to obtain current 3, so we arrive at the value of current 3 as shown in equation 23. For the resistor 2, we have two equations from mesh 1 and mesh 2. So due to mesh 1 we have equation 24 and due to mesh 2 we have equation 25. Substituting the known values we obtain two values, one is a positive value and the other is a negative value. Since mesh 2 gives the higher current value for resistor 2, then we choose this as shown in equation 25. Its direction obeys that of mesh 2. The initial current direction is not all correct since one of them is negative. Here, it would be the first current which is a negative value, and to correct this is to simply reorient this as shown in the figure. We then change the sign to positive from negative.